Assalamu alaikum, myself Mohammad Ashar Khan 23T35. Today I am going to discuss the tree traversal methods, which is breadth first search BFS and DFS depth first search. In First of all, we are going to discuss breadth first search. In this method, we are going to have tree traversal in the form of layers or surfaces in which every root node comes in the form of the order they are placed in horizontal direction. This algorithm use queue status structure, which means first in first out. So first of all, we have imported the library dq, which is used for queue creation, and then we have created a function of BFS in which we have arguments of graph, which is the network or a root node and or a start. And then we have created visited set. Visited set is a variable which take the value of the node which is visited or once. Then we have created a queue in which we have dq from the start. It is the process in which first node come, it enters in the queue, and then we have to dequeue it to dequeue it to get the value and add that dequeue into the visited list, which means that when something comes, it will go into the visited set, visited the data set, and then we have a while loop, while queue. This loop will continue up till the queue will end, and then we have a node queue dot pop left. It means that every value in the queue on the left side will going to the pop when the new value comes in. These pop values are basically the sequence of our BFS traversal. Then we have for neighbors. This for loop is inside that while loop, which means that for every value it is going to traverse for neighbor in graph node, which means that every neighbor of the node, it is checking that if the neighbor is visited or not. If it is not visited, it is going to add into the neighbors and append that into the queue. So basically this is the code for BFS. If we take the scenarios out, which means that maths have the sub child this, physics have sub childs, which is inside that braces, and say basic and all the way to the programming, electronics, signals, and AI. When this code run, the scenario one, our output will be in the form that maths, physics, programming, electronics, signal, AI, networks, in the all way. And then if in that way, which means this is the first layer, then second layer, and third layer. And the scenario, in second scenario, we have city center, mall, hospital, university, airport, stadium, and industrial areas. If we, and third scenario, which is hub, light, camera, fan, thermostat, door locks, and speaker, which is showing like this. So this is the BFS. Now we are going to look for DFS. Now if we see the graph of BFS scenario 1, which are the courses of university. So basically that is math and its two child, physics and programming. And then physics have two subcategories, which is electronics and signals, and programming have AI and networks. So first of all, math will go in the visited set and enter in the queue. This queue will pop the math and the sequence will give us the maths. And then we have to go into the second layer, which is physics and programming. We can take any one, but we will start with physics. Physics will go into that queue. Physics will pop out from that queue, and then it will enter in this order, and then programming will enter in that visited set, and from that neighbor command, which is here. Basically it is going from, after that we will traverse to the more subcategories, which is electronics, signal, AI, and network. So this is the basic functionality of BFS. and the implementation in the form of Python. Then we have DFS algorithm, which is depth first search. In this algorithm, we traverse deep down in the first direction, and then when there is no subchild of that parent, which is the last leaf node. So last leaf node, from that point we traverse back in the different direction. So here we have DFS function in which graph node visited is equal to none, which means that if we have the start of our graph, which is the root node, and we have visited not visited any or traverse any of it side, so in this case if visited is none, so visited is equal to set, which means that the in visited variable first value of graph will be stored, and then that is added into the node. Node is above declared variable, and then we are going to print it. Basically DFS work on stack pointers, stack data structure in which last in first out method is used. So and then it will check for neighbor node. If for a neighbor node that has a loop for neighbor in graph node, if neighbor is not invested, if neighbor is not invested, which means that we haven't traversed for neighbor yet, then this function will be called for the neighbor and it will visit it. For the graph 1 scenario, if we see that it's DFS, so here we have in output terminal, which is math, physics, electronics, signal, network programming, and AI. Math, physics, and then electronics, which means that it is deep going down towards its first branch and then coming back for the second one, which is left. And same is for graph 2 and graph 3. In case of DFS, depth first search, the first root node is our maths, and then we have to go deep down in one direction, which means we have to go to the physics and then electronics, and we have to go trace back to the physics and then signal. From signal we have to trace back to the physics, as there is no root child, no subchild of signal as there, physics, and then math. From math we have to go to the programming, and then programming will be added in our order. From programming we go to the signal, and from AI, and from AI we trace back to the programming and then networks in the end. So this is the interpretation of our working of DFS tree for scenario 1, and the rest will have the same scenarios and patterns.